Okay, we have a problem here involving a 30, 60, 90 degree right triangle. Okay, and that kind of triangle is going to come up a lot in trigonometry, but we're just getting a start at it right here. So suppose we have one of these triangles and the shortest side is 5. What are the other two sides? So I'm going to start by just drawing a little diagram of this. And it doesn't have to be real accurate, but the bigger angle, 60 degrees, I'm going to put here. 30 degrees there. That's the right angle. Now it says that the shortest side is 5, so I'm going to put a 5 right here. Okay, now suppose that you hadn't done any of the reading, so you didn't know the relationship between the sides in any 30, 60, 90 degree right triangle, and you wanted to do this problem. After you looked at it for a while, you'd say this to yourself: well, if I just redraw it over here on this side, so that that's a right angle, that's 60 degrees, and that's 30 degrees, then if this triangle and this triangle are the same, that side also must be 5. Now I look at the triangle and see that each of the 3 angles in this big triangle is 60 degrees. All the angles are equal, so all the sides must be equal. So right away you find out that this side is 10, this side must be 10, and this side must be 10. So you say, okay, I got that second side right there. What about this side right here, x? Well, I can use the Pythagorean theorem in my little red triangle here and get this. X squared plus 5 squared is equal to 10 squared, just the Pythagorean theorem. So x squared plus 25 is equal to 100. I'll subtract 25 from both sides and get x squared is equal to 75. So I'll take the square root of both sides of this equation. I know that x must be a positive number, so I'm just going to have the positive square root right here, positive square root of 75. And then I know from my work with radicals that 75 is 25 times 3, so 25 is the largest perfect square that's a factor of 75. And then using my properties of radicals, I know that this is square root 25 times square root 3, which is going to be 5 square root 3. So that's my third side. So one side's 5, that's the given side. The longest side is 10, and the other side turns out to be 5 square root 3. So in the book, what we did is we generalized this, and by doing this exact same thing, we said this: if you have a 60 degree, 30 degree, 90 degree right triangle, and the shortest side is x, just like this right here, the longest side is always going to be equal to 2x, and that third side is always going to be equal to x square root 3. So that's the little method that we use to generalize this right here. We're going to use these 30, 60, 90 degree triangles a whole bunch in this class, so it's good if you know this relationship. But look, even if you don't know that relationship, you can derive it yourself like this. So the problem's very doable. Let me go back down here to this and just remind you that as far as radicals go, if you have the square root of a times b, you can always write that as square root a times square root b. That's one of our properties of radicals. Same thing happens with division. Square root of a over b will always be the square root of a over the square root of b, as long as b is not 0. What doesn't work? Well, this doesn't work. Square root of a plus b is just not equal to square root a plus square root b. It just doesn't work. And the same thing when that's subtraction, that doesn't work either. So we can't take the square root of a sum is not the sum of the square roots. The square root of a difference is not the difference of the square roots. But the square root of a product is always the product of the square roots, and the square root of a quotient is the quotient of the square roots. What else would you need to know right here about square roots? Square root of a squared is equal to a. And I'm just going to add in here for all of these things that I've written right here, a and b are greater than or equal to 0 unless I specify that b is not 0. So most of the time when we're doing these things in trigonometry, A and B will be positive numbers. So it makes all of these properties of roots in that very easy. So you want to be able to do this right here. It's a little review of what you did in algebra with square roots. It's going to come up from time to time, both this way with multiplication and this way with division. So in any case, 30, 60, 90 degree right triangle, important triangle in trigonometry, and here's one of the first problems that we've done with it.